Now, before we cache it though, there's a few other things I'd like to do. One of the main ones is observe that when we make fractures, or we'll look at it here, it makes some groups for us. It makes, and specifically an inside and an outside group, which is what it sounds like. The outside is everything that was here already before we fractured, and the inside becomes anything that's new. I'm going to turn off the proxy geometry here for a minute. So I'm going to press S to go into selection mode, and then I'm going to click this thing here, or you can press 9, and you can see it shows us all the various groups that are here. Outside, I'm going to turn off the colors by clicking on that. Outside is everything that, again, was on the outside, whereas inside is this new stuff here. Thinking ahead, we're going to want to assign different materials to these different areas. The outside will probably be a darker, more weathered look. The inside is freshly exposed. It should probably be brighter maybe, and maybe have some more roughness to it or something. So that's a really convenient thing to have, is those two groups. But if you think about it, a wall like this really is kind of its own sub-fracture of the larger building. Meaning, if these areas, if these thin areas like here are exposed, they really should have the interior material as well. So let's define our own outside and inside groups before we even get here. This will not overwrite them, it'll simply update them. So go into selection mode with an S, right click here, and go to area, select visible geometry only. I want to make sure that I don't select both sides of this by accident. So put a group down. I don't think that showed up, but there it is, group. Go to it, and we're going to say, let's define what the outside is. The outside can be defined by clicking on this here, and then literally clicking and shift clicking. Press enter, and there you go. So that's the outside. What's the inside? Well, it's everything else. So do a group combine and say the inside equals everything but the outside. If we want a quick and dirty way of seeing that result, we can click on group combine and click this manipulator and you can see it. Or as we saw before, we can go into this mode and hover over it. And then you can see the difference. Great. So given that, and now it will have to refracture it, and we can see that the inside now is all the new inside stuff, and it's these thin strips around the outside as well. Because again, you can kind of feel it now maybe more instinctively, how these would be also raw surfaces, I'll say. So that's cool. And the last thing along these lines is I like to do a little pre-fracturing before I let this thing take over. Lots of ways you can do that, but for this lesson I'm just going to say make a plane that kind of is aligned with the thing we're fracturing, like so. And then I'm going to put a Boolean fracture here, which will also respect the inside and outside group stuff. And much like when we made our regular Boolean node before, this will perform an operation on original geometry and the new geometry, and then output something new. So if I do an exploded view here, we can see we now have two pieces. The significance of this is we now have literally, oh, I didn't promise not to use that one. I'll use this one. We now have a piece 0 and a piece 1 already. So the RBD material fracture can be told, fracture per piece, look for, and wait for it to show up, look for the name attribute, and then do separate fractures. So now if I look at this, we get this look, which I like a lot more. We have two layers. It's almost as if we have two layers of sheetrock, or we have a plaster on the outside and then a sheetrock, or there's a wood backing or something. The purpose of it generally is that we're going to get much more interesting shapes later on. When we glue all the pieces to each other, you know, this piece here, this big chunk, might be glued to this big chunk. So we'll have a much more interesting outline like this, and it'll have a more interesting outline even in this dimension. It will look like a staircasing kind of effect. So it'll just feel more like brittle construction material, you know, in my opinion. We have more pieces, of course, but we can afford it. So, pretty cool. And the same still applies. If I look at the groups, the inside groups will be all of that stuff on the inside now, but still everything on the outside will remain the outside group. So with that all in mind, if we go back down to here, it's still the fracture from before. We need to save it and reload it. And now we have it. So do an unpack RBD, because we have a few more things to do before we finish this. We only cached it here because, again, this was all the heavy lifting, the fracturing and whatnot. There's lots of times we might want to change smaller things about this. I'm going to copy and paste this actually down here, like so. Uh-oh. There's some smaller things we might want to do down here without wanting to recache our geometry or refracture it. That's mostly going to be stuff like changing the material. We don't have any materials set up yet, but they will probably almost always be in terms of the inside, and I pressed plus there, and the outside. And then we'll assign our material here. Again, we don't have them yet. But if we want to swap our materials out and whatnot, we don't want to refracture everything, and we don't want to recache everything. We just want to change it at the last second here. So that's why that's after our file cache. We also don't need to change the material on the proxy geometry here because we're never going to see the proxy geometry rendered. So here's our rest node. The rest node simply copies the P attribute into the rest attribute. This will be used for 3D noises. So if we want to do displacement or bump mapping later, we just want to know where the geometry originally was and not where it is now during the sim. So just think of it as UVs, three-dimensional UVs in a sense. And the last thing we'll want is a really quick lesson in cleaning up of the fracture here. Sometimes, the fracture does a really great job, but sometimes it can make problematic pieces that look like polylines. And what I mean by polylines, and you don't have to do this, just watch me do this. This looks like this. This is still a polygon as far as Houdini is concerned, just the same as the others are polygons. But we look at this and we see a thin line because this is not a closed polygon. A closed polygon is a surface like so, where the last point connects back to the first point. Open ones look like this. Sometimes the RBD material fracture can make these. Usually this happens with geometry that's a little weirder, like it can happen with the one with the windows in it, for example. So all I want to do is point out that polygons, primitives in general in Houdini, have a thing called intrinsics. They are called primitive intrinsics, in fact. They are invisible attributes you don't usually see. They live here under the intrinsic menu. The one we're interested in is called closed. It is either closed or it's not. So if we close it, it's closed. If it's not, it's not. Why are there secret attributes and why are they called intrinsics? Because intrinsics almost always are more fundamental to the very nature of the primitive. You know, when we save things, when we save arbitrary attributes on here, like what group is it or whatever, it doesn't really fundamentally change what it looks like or what it does. But the intrinsic here, as you can see, is very fundamental to the nature of the primitive. That's, in a nutshell, more or less why. So all that is to say is we know that there's an intrinsic called closed. So we just need to query that with a primitive wrangler to see whether it is or it isn't. And if it's not closed, we simply need to destroy this primitive. So the way we'll do that is say if, and we need to get that. So prim intrinsic, the incoming geometry, closed, and which one do we want to query? We want to query primnum at primnum, which is a built-in attribute, which means the current primitive that this bit of code is currently running on. Remember that this will run on every primitive in parallel. So this will return either a 1 or a 0. So if it is equal to 0, meaning it is not closed, then we need to remove it. So remove prim is a function that does that from 0 again, incoming geometry, primnum again, the current primitive we're even talking about, and then there's this extra argument here, 1, which says also delete the points. And put a semicolon at the end, and you can see it did nothing because this is closed. But if I were to say it's not closed, and I look at it again, we can see it's gone. We still saw it when this was clicked, but the actual result of this node is gone. So let's just throw that. This could actually probably go before this RBD pack here. And for what it's worth, I have this RBD pack here just to make saving it easier. So there's just one output, and then we can split them back up again here. So there you go. That's pretty much it. To finish up here, we want to do an RBD configure, which will take the high res again and the low res again, and that's this input here, the third one, not the last one. It will, with some encouragement, there we go, it will pack these things back up. So apparently there are 100 primitives here. And then we can RBD pack this whole thing up back down into one thing again. And then we can make this be the null here at the end. Great. So this is the general sketch of what we're going to do to all of our things. Obviously, we're not going to make all these nodes all over again. We're going to copy and paste it, but we're going to change the orientation of this grid each time. We're going to change what is the outside and what is the inside. And that's pretty much it. Everything else should pretty much be the same. And later on, I guess, we'll change the material. So again, just making these green so we can see them more easily. Awesome. So let's go make the other ones. Actually, I thought of one more thing that would be nice to do. You know, we're littering these exploded views all over the place. Let's do actually one more. I kind of want to have the result of all this. So I'm going to take this. Even though these are now packed pieces, this will still work, like so. I'm not sure why we're seeing that. That's another viewport bug again. Again, yeah, it's going to keep happening. There we go. It's gone now. But what I wanted to say was, if we put an output node here, this is a nice, I'm going to call this display. This is a nice little bit of thing here where I could have my actual display flag on anything. But because this is here, when we're looking at the result of this geometry node, it's going to show us this. So it'll just be nice as we populate this with the other ones that we can quickly always be seeing the fractured version of it. Yeah. Just a thought. So there you go. Save that, and now let's move on to the rest of them.